I want to discuss a method for finding the charges on the polyatomic ions. And the best thing about this method is that it doesn't have any exceptions. It covers all the polyatomic ions, and especially the mentioned polyatomic ions, which I'm going to use here. So, before discussing about this method, I want to discuss about the fundamental concepts behind this. For example, the polyatomic ions are consist of these nonmetals, and a nonmetal will always form a covalent bond. For example, we know about the carbon and carbon. They are depicted by this dot structure method. This is called dot structure method. For example, if a carbon has one electron, this carbon has one electron, and if I form a dot structure, so now it will have and two electrons. Okay, so this is what I'm going to use here. And the second part, second concept will be that after making the draw structure, for example, I have one carbon and I have one oxygen here, one oxygen here, and one oxygen here. Sorry, this oxygens. Okay, and first thing will be that I will form a dot structure method. Then I will write the valencies. For example, oxygen has six, so now it will become seven. Okay, this will also will have seven. This also will have seven, and this is also four plus three seven. Okay, and after this, if any atom has more than eight electrons in their outer shell, then it will donate this electron to any atom that needs it. Okay, so this is the important thing about donating electron. It can be done more than one time, but this sharing, okay, after making dot structure with every atom one time, I will I can only make one more time this dot structure, and this will not exceed not exceed one time. I will not make more than one time this dot structure. Okay, so sharing will be only once after completing the dot structure, and it will be more simplified if I will use it here for examples. So what I'm trying to speak is that donating electron when the numbers will exceed eight, it can be done more than one time. But the sharing after making the dot structure with every atom once, I can do sharing only one. Okay, so this is the important thing. So now starting with the first, let's say carbonate atom. So atom, this is our second atom, and this will be our third atom. Okay, now I will start joining them. So what I was saying is that I will make first step will always be to connect these electrons. Okay, oh, and connecting this, and so this will be our first step. Okay, to finding out charge on any polyatomic ion. Firstly, we will connect these uh, electrons only once. Okay. Now, after this, I will write the valency like on the this carbon. It had earlier 4 plus 3. Now it had 7. It has 7. It has 7. It has 7. So now what I have said that after this, I can see that I can also make one more time these sharing of electrons. I mean dot structure. And the important thing that I had said, but I can only use this once. So I will use it. Now I have 8 here and 8 here. After this, no more sharing, no donating is available here. So I will write the charge. Okay, so I need one electron here and one electron here to fulfill their outer octet. So I have charge on the CO3 as 2 minus. Okay, moving on the next. Okay, NO2. This is known as nitrite ion. Okay. Mhm. So for the nitrate ion, what I will do is I will take out one nitrogen atom here. I will be for the nitrate, sorry, okay. Then copy NO. I will try with firstly NO2. Okay. So red. Now my first step will be to connect this, writing the new valency as this is 7, this will be 7, that's 5 plus 2, 7 again. And I have said that I can use this again, I mean sharing only once. So I will use it, and now it will become 8. This will become 8, and it needs one more electron to fill this outer octet. So I will write it when charge of this polyatomic ion is 1 minus, because it needs one electron for this oxygen atom. So now moving on the next and the oxygen atom. One, two, three. Now I will connect them. Okay. So first step will be making dot structure with this, dot structure with this, and this. Now I will write this is 5 plus 3, 8. This is 7. This is 7. This is 7. Now I can make the as one dot structure again. Now I have I can't make one more, okay? I've already used this. So this will become 9, okay? And for this it will become 8. But remember what I have said, if the base atom, suppose if the base atom exceeds electron number in its outer shell more than 8, it can donate one electron. So I will donate one electron to this. It will become 8, and this will also become 8. Now I need one more electron here to complete. So it's a new charge. I will write it as NO3 and 1 minus. Okay, now moving on to the next. PO4, that is phosphate polyatomic ion. PO4, one oxygen atom here. So now my first step will be to connect them once. Again, this, this. Now writing the valencies. 1, 2, 3, 4, 5, 5 plus 4, 9. 9, this is 7, 7, 7, and then here 7. Now I would like to donate one electron to this. So it will become 8. And this will become 8. Okay, I've donated this. Now I have 3 atoms here. So I can write, no sharing is needed. Okay, PO 4 minus 3 minus recharge. Okay, so moving on the next SO2, which is also known as SO, not SO2, it is SO3, which is our sulfide polyatomic ion. So here is our SO3, which is also known as sulfide. So connecting, sorry. So yeah, our first step will be to connect them on this. New valencies will be 7, 7, 7, and this is 6 plus 3, 9. Now I will donate one electron to this, so it will become 8. So I will write its charge as SO3 and 2 electrons it needs, 2 minus. Okay. Now for SO4, oh, so for SO4, I will connect this 7, 7, 7, 7. And this has 6 plus 4, 10. Now it has 10. So it has two extra electrons. So first it will give to this, and second to this. It will become 8. This will also become 8, and this will now become 8. So its new charge will be 2 minus. I mean, it's need 2 electrons. So SO4, 2 minus. Okay. So I think in the same way you can find the polyatomic ion for NH4 as a plus 1, which I am leaving it for you to draw it. And you can also try it for HCO3, which I will give you one hint that firstly determine for CO3, which will come out to be -2, and then try making a covalent bond with hydrogen. Okay, as a one electron. Okay, so if for example CO3, I can write it like CO3. Yes. So what this -2 valency for CO3 means is that 8 minus 2, it has 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6, and it has one oxygen for hydrogen. If I connect this, it will now have 2, it will now have 7, it needs one electron here. That's why its charge is 1 minus. Okay, so likewise, you can try for many polyatomic ions as well. So thank you.